Okay guys, welcome to my channel. In this video I want to talk about VLANs. A VLAN or virtual local area network is a virtualized connection that connects multiple devices and network nodes from different LANs into one logical network, or is a logical overlay network that groups together a subset of devices that share a physical LAN, isolating the traffic for each group. Without VLANs, a broadcast sent from a host can easily reach all network devices. Each and every device will process broadcast received frames. It can increase the CPU overhead on each device and reduce the overall network security. In case if you place interfaces on both switches into separate VLAN, a broadcast packet sent to the specific VLAN which is located to the specific interface. For example, a broadcast from host A can reach only device available inside the same VLAN. See? The packets only goes to VLAN 1. Hosts of VLANs will not even be aware that the communication took place. VLAN technology enables network architects to segment physical devices into logical subgroups for performance and security reasons. As we discussed about LAN, a LAN is a group of computers or other devices in the same place, like the same building or campus, that share the same physical network. A LAN is usually associated with an Ethernet Layer 2 broadcast domain, which is the set of network devices an Ethernet broadcast packet can reach. Computers on the LAN connect to the same network switch, either directly or through wireless access point connected to the same switch. Once traffic crosses a router and engages Layer 3 functions, it is not considered to be on the same LAN, even if everything stays in the same building or floor. As a result, a location could have many interconnected LANs. A VLAN, like the LAN, operates at Layer 2 of the network, the Ethernet level. VLANs partition a single switched network into a set of overlaid virtual network that can meet different functional and security requirements. This partitioning avoids the need to have multiple distinct physical networks for different use cases. The purpose of a VLANs for multiple reasons, including improved performance. VLANs can improve performance for devices on them by reducing the amount of traffic, and VLANs break a broadcast domain, reducing the number of other hosts from which any given device sees broadcasts. For example, if all voice over IP phones are on one VLAN and all workstations are on another, phones will not see any workstation generated broadcast traffic, and vice versa. Engineers can also define different traffic handling rules per VLAN. For example, they can set rules to prioritize video traffic on a VLAN 4 that connects conference room equipment. Also, VLAN partitioning can also improve security by enabling a higher degree of control over which devices have access to each other. For example, network teams may restrict management access to finite devices to specific VLANs. Using VLANs to group endpoints also enable administrators to group devices for purely administrative, non-technical purposes. For example, they may put all accounting computers on one VLAN all human resources computers on another, and so on. Types of VLANs. Network engineers create port-based VLANs by assigning ports on a network switch to a VLAN. Those ports only communicate on the assigned VLANs, and each port is on one VLAN only. While port-based VLANs are sometimes called static VLANs, it is important to remember they aren't truly static because the VLANs assigned to the port can be changed manually or by network automation. I will discuss about VLAN configuration in the next video. Also, network engineers use basic VLANs by assigning traffic to a VLAN dynamically, based on the traffic type or the device creating the traffic. One port can be associated with multiple dynamic VLANs. Some VLAN types are defined by the type of traffic they support, others are defined by the specific functions they perform. For example, data VLAN, configured to carry only user-generated traffic, ensuring that voice and management traffic is separated from data traffic. Default VLAN, all the ports on a switch are members of default VLAN. The default for Cisco switch is VLAN 1. VLAN 1 has all the features of any VLAN, except that you cannot rename or delete it. Black hole VLAN, all unused switch ports are assigned to the black hole VLAN. A security-based practice is to define a black hole VLAN so that any unauthorized device connected to an unused switch port is prevented from communication. Native VLAN. This VLAN type serves as a command identifier on opposing end of a trunk link. A security-based practice is to define a native VLAN. Management VLAN. The network administrator defines this VLAN as a means to access the management capabilities of a switch. By default, VLAN 1 is a management VLAN. Voice VLAN. The voice VLAN feature enables switchboard to carry IP voice traffic from an IP phone. The network administrator configures a voice VLAN and assigns it to access ports. Thank you for watching this video. If you like this video, please subscribe my channel and share with your friends.